Hello, all. Welcome to the day 15 of the daily case study series for Cbse grade 12. Today's question goes like this. A plane started from an airport situated at O with a velocity of 120 meter per second towards east. Air is blowing at a velocity of 50 meter per second towards the north as shown in the figure. The plane traveled 1 hour in the OP direction with the resultant velocity. From P to R, the plane traveled 1 hour, keeping velocity of 120 meter per second and finally landed at R. Based on the above information, answer the following questions. First subdivision, what is the resultant velocity from O to P in meter per second? Velocity of the plane and velocity of the wind are perpendicular to each other. So the magnitude of OP vector can be derived by using the Pythagoras theorem. Magnitude of OP vector is equal to square root of 120 on the east, 120 square plus 50 square. Square root of 12 is 144 plus 2500, which is 169 followed by two zeros. That is nothing but 130 meter per second. So the option is B. Second subdivision, the direction of travel of plane from O to P with east is direction of travel. So this can be achieved by figuring out the angle between OA and OP. Tan theta is equal to opposite, which is 50 by adjacent. Theta is nothing but tan inverse of 5 by 12. So the option is A. Third subdivision, what is the displacement from O to P in kilometers? The question is asking for displacement. From O to P, we have derived the resultant velocity already in the first subdivision. So resultant velocity from O to P is equal to 130 meter per second. This is in meter per second. So let's convert this to kilometer per hour. So 130 into 18 by 5 kilometer per hour, which is 468 kilometer per hour. So from O to P, the time duration of travel is 1 hour only. So ultimately the displacement becomes 468 kilometer. Option is B. Subdivision 4. What is the resultant velocity from P to R in meter per second? The question says from P to R, the plane traveled 1 hour, keeping velocity of 120 meter per second. So the velocity of the plane is 120 meter per second. Because it is flying in the direction of the wind, it's going to add up. Resultant velocity from P to R is equal to 120 meter per second plus 50 meter per second, which is 170 meter per second. So the option is C. Fifth subdivision, what is the displacement from P to R in kilometer? So in fourth part, we have got the answer in meter per second. So let us convert that to kilometer. 170 meter per second is equal to 170 into 18 by 5 kilometer per hour. After calculation, we will get 612 kilometer per hour. From P to R, the duration of travel is only 1 hour. So displacement will become 612 kilometer. So the option is D. Sixth subdivision, if P vector is given by and R vector is given by, then find out the value of the magnitude of PR vector. PR vector is equal to position vector of R minus position vector of P. That is 7i plus 5j plus 2k minus I plus 2j plus 4k, which gives us 6i plus 3j minus 2k. So magnitude of PR vector will be square root of 6 square plus 3 square plus minus 2 square, which is root 49, which is equal to 7. Subdivision 7. What will be the area of triangle POA, where A is the vertical meeting point of the plane from P and A is given by this vector? Area is equal to half times magnitude of OP cross OA, which is equal to half times magnitude of, we'll find out the cross product, which is equal to half times I into 2 plus 8 minus j into 1 minus 16 plus k into minus 2 minus 8, which is half times magnitude of 10i plus 15j minus 10k, half times square root of 10 square plus 15 square plus minus 10 square, which is equal to root of 100 plus 225 plus 100, that is half times root 425. 425 can be written as 25 times 17. So it is 5 by 2 root 17 square units. Let's get back with another case study question tomorrow. Thank you all.